This is the KF-21 Boramae. It took 11 years to build, cost $7.7 billion to develop, and on the morning of its first flight, the test pilot reported it flew exactly as the simulations predicted. 11 years of engineering, one sentence of confirmation. That is how you know a program went right. But here is what the headlines got wrong. They called it a 4.5 generation fighter, noted the vague resemblance to an F-22, and filed it under American ally builds decent jet. That framing misses the entire point. The KF-21 is not a knockoff of something American. It is a direct engineering response to something America refused to hand over. The gap between imitation and answer is where the real story lives. Washington denied Korea the stealth technology transfer. Korea built around the denial. What resulted is an aircraft optimized not for missions. The F-35 was designed to fly, but for the specific geometry of the Korean Peninsula, the specific density of the threat environment above it, and the specific maintenance reality of a country that needs its jets airborne every day, not just on the days the coding holds. The KF-21 is not trying to be invisible. It is trying to be something harder to kill than invisible. There is a difference. Start with what is under the skin. The engines, the first answer to dependency. The KF-21 runs on two General Electric F414-GE-400K turbofans, the same engine family that powers the F/A-18E/F Super Hornet. Each one produces 22,000 pounds of thrust in full afterburner. Two of them together push 44,000 pounds of thrust against an airframe that weighs 33,000 pounds. Empty. Thrust-to-weight ratio above 1.0. That means at combat weight, this aircraft can accelerate straight up. Not climb, accelerate. But Korea did not simply purchase these engines. They negotiated, over years of difficult talks, the right to manufacture them domestically through Hanwha Aerospace. That distinction sounds like procurement bureaucracy. It is a strategic decision of the first order. When you buy engines from a foreign supplier, your Air Force's operational readiness is a function of whether the shipping lane from Ohio to Sacheon stays open. When you manufacture the engine yourself, your jets fly regardless of what the alliance looks like in a crisis. For a country sharing a land border with one of the most erratic military establishments on the planet, that is not a secondary consideration. It is the entire premise. Hanwha's licensed production means Korea controls the maintenance cycle. Turbine blade replacements, compressor overhauls, hot section inspections, all on Korean soil, on Korean timelines, with Korean-trained technicians. A fighter jet grounded waiting for foreign parts is not a fighter jet. It is expensive infrastructure decoration. Korea decided it would not build its future on that risk. The airframe, a placeholder that is not a compromise. Look at the KF-21's shape. Canted twin tails, a blended wing-body junction, leading and trailing edges aligned to reflect radar energy in coherent directions rather than scattering it. These are not coincidences of aesthetics. They are stealth design principles applied deliberately to an airframe that America's export control framework says cannot be a stealth aircraft. Here is what was denied. The internal weapons bays that keep missiles flush with the fuselage and out of the radar cross-section. The specialized radar-absorbent material formulations and curing processes that turn a shaped airframe into a true low-observable platform. The coatings and their application methods. The reason cited in the denial was export law. The structural reason is simpler and more honest. You do not transfer the technology that makes your most expensive aircraft worth the price tag. So Korea's engineers made a decision that is either pragmatic genius or deferred reckoning, depending on how Block 3 goes. They designed the Boramae's fuselage now to accommodate internal weapons bays later. The structural geometry is already there. The internal volume is reserved. The wiring pathways are accounted for. Block 1, which is what is flying today, carries weapons on 6 external hardpoints and 4 wingtip rails. Visible, radar reflective, effective. Block 2 adds precision ground attack with expanded munition options. Block 3 projected for the early 2030s, integrates the internal base and completes the low observable configuration. The aircraft flying today is, by design, an unfinished sentence. Korea wrote the first half knowing what the second half would say. The fuselage is also covered in radar-absorbent material developed domestically by the Agency for Defense Development, not the classified American formulations, Korea's own. The exact reduction in radar cross-section is not public. What is known is that Korea's engineers were not covering the airframe decoratively. Every gram of coating is weight, and weight costs range and payload. If it is on the aircraft, it is earning its place. The radar. 11 years from nothing. 39 inches behind the radome sits the thing Korea was most emphatically told it could not build. The RAKSA is an active electronically scanned array radar developed by Hanwha Systems after over a decade of domestic research. It contains over 1,000 transmit-receive modules. Each module is a semiconductor device capable of independently steering a radar beam in microseconds, with no moving parts, no mechanical gimbal, no physical antenna rotating inside the nose. The beam goes where software tells it to go, and it gets there faster than any mechanical system can follow. What that means operationally: the RAKSA can track 20 separate air targets simultaneously while building a terrain map of the ground below. It can execute an electronic attack against an enemy radar using its own aperture as the jamming emitter, then flip back to search mode in the same scan cycle. It does not have to choose between finding targets and disrupting the systems hunting it. It does both at the same time. More importantly, it is Korean. Every algorithm, every processing architecture, every classified operating mode. Korea did not buy a foreign AESA and negotiate partial access to the software. They built the software, which means upgrades happen when Korea decides they should happen, not when a foreign prime contractor's development schedule permits. New waveforms, new low probability of intercept modes, fusion with satellite sensor data. None of that requires a foreign government's approval. The radar is sovereign in a way that a purchased system never could be. The IRST, infrared search and track sensor, sits under the nose in a conformal fairing. It detects heat signatures passively. No radar emissions, no electromagnetic footprint. Against an adversary whose air defense network is listening for exactly those emissions, the ability to find, track, and target without broadcasting your location is not a feature. It is survival arithmetic. The threat. What the peninsula actually looks like. North Korea operates roughly 800 combat aircraft. The majority are variants of the MiG-21 and MiG-29. Aging airframes, but not irrelevant at short range on a peninsula where distances between Pyongyang and Seoul can be covered in minutes at military speed. But the aircraft are almost beside the point. The real problem is the surface-to-air missile density. North Korea has constructed one of the most layered ground-based air defense networks on Earth. Legacy SA-2 and SA-5 systems from the Soviet era, domestically modified variants of more modern platforms, and thousands of radar-guided and optically aimed anti-aircraft artillery pieces embedded in hardened positions throughout the northern terrain. The AAA emits nothing detectable. It is simply there, in numbers, positioned to engage anything that flies low enough to avoid the radar-guided missiles, creating a vertical compression problem that forces aircraft into an engagement envelope they cannot fully avoid. The opening hours of any conflict on the peninsula are not a patrol environment. They are a saturation problem. Whatever Korea flies into that airspace needs to either be genuinely invisible, genuinely unjammable, or genuinely fast enough and far enough away to release weapons before the kill chain closes. The KF-21 is optimized for the third answer, supported by enough of the first two to make the engagement geometry hostile for the threat. Full stealth achieves low observability. The KF-21 achieves low probability of intercept through a combination of semi-stealth shaping, active jamming from the RACSA aperture, passive search via IRST, and standoff weapons that put the pilot outside the effective range of most systems before a shot is ever taken. Different mechanism, similar result. at significantly lower maintenance cost per flight hour. The weapons. Reach before risk. The Meteor Beyond Visual Range missile uses a ramjet motor that sustains thrust all the way to target. Most radar-guided missiles are coasting by the time they reach maximum range. They burned their fuel early and arrived with diminishing energy and diminishing maneuverability. The Meteor is still accelerating at the end of its run. Against an adversary aircraft performing evasive maneuvers at max range, that energy differential is the difference between a miss and a kill. The Taurus KEPD-350 standoff cruise missile extends the ground attack reach to 500 kilometers. The KF-21 can release it from 30 miles outside heavily defended airspace, well outside the effective envelope of most surface-to-air systems, and the missile navigates to the target autonomously at terrain-following altitude. Underground command bunkers, hardened artillery sites, runway shelters, the pilot designates, releases, and turns for home before the defense network has completed its targeting solution. The IRST covers close-in engagements with a high off-boresight infrared seeker that can engage targets the pilot is not pointing at. Helmet-mounted sight integration allows designation simply by looking at the threat. The missile turns to match. Within visual range, combat on the peninsula is close, fast, and decided in seconds. The IRST compresses those seconds in Korea's favor. The Sortie. From ramp to kill to recovery, a standard air superiority mission launches from Cheongju or Gunsan Air Base. Taxi, takeoff, roll, wheels up. The KF-21 reaches its combat air patrol station over the Han River corridor in under 10 minutes at military power. The AESA activates in low probability of intercept mode, emitting in burst patterns that the enemy's electronic surveillance systems read as background noise rather than active radar. The IRST scans the northern threat axis passively. No emissions, no detectable signature. A contact builds on the fusion display. Not a separate radar track and a separate IRST contact, requiring mental integration by a pilot under G-load and time pressure. One fused picture. One designated track. 2 seconds from contact to fire control solution. The Meteor comes off the rail at 60 miles. The engagement ends before the adversary pilot's radar warning receiver completes its classification. He may not know there was an aircraft there. He may not know anything after that. Recovery. Single instrument approach. Touchdown. Ground crew on the jet within minutes. Turnaround time to the next sortie. Under 30 minutes for a standard configuration check. That number is where the real comparison with the F-35 lies. The arithmetic that decides wars. The F-35's low observable coatings require between 50 and 100 man-hours of maintenance per flight hour to sustain their combat effective state. Every mission that stresses the coating, rain, heat, abrasion, weapons carriage, degrades it measurably. That degradation must be repaired before the next mission, or the aircraft's central capability is compromised. The F-35 is extraordinary. It is also extraordinarily fragile to maintain at scale. The KF-21's maintenance burden is comparable to a conventional fourth-generation fighter, heavier than an F-16, lighter than an F-35 by a significant margin. In a conflict measured in days, that difference is manageable. In a conflict measured in weeks, which any serious planning scenario on the Korean Peninsula must account for, sortie generation rate becomes the decisive variable. An aircraft that flies 4 sorties per day defeats an aircraft that flies 2, regardless of which one is technically superior in the air. Quantity has a quality of its own, and the KF-21 is designed to be available. Korea has contracted 120 KF-21s in its initial production run. At $65 million per unit, that is an affordable fleet by any modern standard. Indonesia holds a co-development agreement for 48 aircraft with licensed domestic production rights, a partnership that has faced payment difficulties but remains structurally important for Korea's export ambitions. A jet only one country buys is an expensive national project. A jet other countries buy is the beginning of a defense industry. The close. What July 19, 2022 actually meant. On July 19, 2022, at Sacheon Air Base, KF-21. Prototype 1 released its brakes and began its takeoff roll. Test pilot Colonel An Jun-young rotated at the calculated speed, lifted cleanly, and flew a 33-minute first flight that confirmed what 11 years of simulation had predicted. He landed. He reported. The aircraft flew as designed. That sentence, "The aircraft flew as designed," is the whole story. Programs that fail produce aircraft that surprise their test pilots. Programs that succeed produce aircraft that confirm their models. Korea confirmed its model on the first attempt, on an entirely indigenous airframe, with a radar built from scratch after being told the technology was out of reach, on engines it manufactures itself, wrapped in coatings its own engineers formulated. The KF-21 is not the world's most advanced fighter. It is not trying to be. It is trying to be the most capable fighter Korea can build, sustain, upgrade, and fly in the numbers the peninsula requires. There is a strategic maturity in that choice that most coverage misses. Knowing what you need and building exactly that, rather than buying what your ally is willing to sell, is not a consolation prize. It is sovereignty expressed in aluminum and software, and 11 years of hard engineering. The next time you see the Boramae's nose on the ramp at Sacheon, you are not looking at a compromise. You are looking at a country that was told no and built yes instead.